Welcome to the lecture series Programming in C. In this module, we will be focusing on formatted input and output statement with respect to print and reading. So, in this module, we will be focusing on learning about the printf function, which is an IO function, also a scanf function, which is used for reading values. The printf function is used for displaying the values on the monitor, and scanf function is used to read values from the user again through the keyboard. So, hence it uses the keyboard and the monitor as input and output devices respectively. It is also named as IO formatting functions. The printf function will be using a format string with the which is known as conversion specifier. The format string will be having a symbol percentage associated with the conversion specifications. The conversion specification used in the format string, which will mean that actually what type of value has to be replaced. Also, otherwise it can be named as a placeholder. Say for instance, if it is going to be using a character D, which is a placeholder for integer type of values, and if I am using the format string with the conversion specifier F, which is going to be a placeholder for floating type of values or real numbers. So, we will see the use of conversion specifications with a small example. So, in the example given, the values of I and j are integer values. The values stored with x and y are going to be floating point values. So, we are trying to store an integer value to the variables I and j and floating point values to the variable x and y. So, in case if I have to print the integer type value, I need to use the format string with the conversion specifier D, and if it is going to be a floating point value, we will be using the conversion specifier as F, as we have already seen. So, I need to use the printf statement using the conversion specifier percentage %d and f. So, percentage %d, wherever it is used, accordingly the values will be replaced, henceforth it is named as a placeholder. So, what we are actually using here, I equal to percentage %d. So, this percentage %d will be substituted with the value which we are specifying after the format string. The format string is enclosed within double quotes. So, after this format string, whatever the names we give here, it is all the variable names. So, I, j, x and y are all variable names. So, where we are going to substitute the values of I, j, x and y, in those positions we are supposed to use the format string or the conversion specification. So, I am just using it as I equal to percentage %d. So, this percentage %d, this position will be substituted with the value of I as 10, and this position will be substituted with the value of 20, which is the value of j, and this will be substituted with the value of x, which is there in the next position in the variable list. So, x value will be replaced with 43.289200. We will come to this point why it is named as why it is numbered as 200. Instead, it is just 2892. So, there is a difference in the way that it is getting displayed. Also, I am using the conversion string percentage %f again for displaying the value of y. So, y's value is 5527.0 f. So, which is replaced or which is displayed this way. So, there is a change in the format when it is getting displayed through the printf statement. So, we need to now know, we need to now learn what are all the formats available and in what way we can customize it for the requirements, how we are going to display it for the programs. And there are few things to be checked. The first thing is the compiler has to check whether the number of conversion specification strings matches with the number of output items, in the sense that, so when I am using two conversion specifications in the format string, I should also give two variables after the format string. If it is not matching, if the number is not matching, we will be getting a error with the compiler. And if it is too few conversion specifications also, because here we are representing, we are using two variable names, but then the conversion string is specified to be only one. Again this will raise a compiler error. So, the compiler has to verify whether the number of format string given in the printf statement matches with the number of variables that has to be displayed. So, if the programmer uses an incorrect specification, the program will produce meaningless output, in the sense that I am using %f and %d. Actually %d is for representing the integer value I and %f is for representing integer value x, which is actually to be interchanged. So, in this case it will not show as error, but then the value will not be the actual correct value what we are expecting. With respect to floating point values, there are few formats to be learned with respect to the conversion specification strings. So, general format is %m dot px, where m and p are integer constants and x is going to be a letter. M and p are optional. If you drop it, if you not specifying m and p also, it will not show any error. That is the reason that we can just use it even as %d, %f, but the general format will be %m dot pf or m dot pi, where m and p are going to be integers. What m represents and what p represents, that we should know. If I give it as 10.2 f, m value will be 10 and p value will be 2. So, this is how the general format need to be mentioned. Now, we will see what is m, what is p. M is the minimum field width. If you are specifying some minimum field width, the number of values that has to be displayed have to be fit into that field width. If it is not able to fit into that field width, automatically it will increase or expand the size field width. Say for instance, if I am using m value to be 4, I generally use %d. If I need to use the m value to be 4 %4d, the number to be displayed has only 3 characters or 3 letters. In that case, the extra space will be left at the left side. It means that the number will be displayed with right justification. In case if we want to move it to the left, if we want to move it with left justification, we can, instead representing +4, we can just add a minus symbol, -4d. -4d will move the number to its left if the field width is more. If the field width is lesser than the number of letters which we want to display. Say for instance, I am just displaying using 2 places. The field width which I am specifying is only 2, but the number which I want to display is having 3 digits. No matter, it can just expand its field width automatically. So, we will be just getting the value to be 123 even if the field width is lesser. So, general X character can be replaced with any of these characters which it is displayed. Each character is meant for a special type of data which we want to print. Say for example, if I use C as a character, that will print a single character. If I am using D, decimal number, E is for scientific notation of the floating point value, uppercase E can also be used. F is for fixed point, floating point value, G is also for fixed point and or scientific value, L E stands for long float, L F stands for long float fixed point, L G stands for long float either fixed or scientific, S stands for string, X stands for integer to hexadecimal value conversion and U stands for unsigned integer. We have not yet discussed about the value P. So, we will also discuss about value P, because in the format, the general format m dot p x, we have discussed on the value how m is handled, which is nothing but the field width. X is going to be the character which is going to represent the type of value which we want to display. So, that also we have discussed, and P stands for the precision value which has to be mentioned only the case of floating point values. So, when I want to display floating point value, I need to specify the number of decimal places after the decimal point. In that case, we can have some integer value representation with respect to P. In case if we want to display a numerical value which is going to be an integer, then we can just omit P value. We need not specify any value with respect to P. Now, if the exponential format, if the floating point value need to be displayed in the exponential format, the default decimal point, default number of digits after the decimal point is 6. So, we can make a note that if P is 0, there are no decimal point displayed, and I use F and G. We have already seen that F can be used for fixed point floating point value display. Also G can be used with respect to both the exponential format and fixed decimal format. In both these cases, P will represent the maximum number of significant digits to be displayed. G conversion will not show trailing zeros. If the number has no digits after the decimal point, G conversion specifier will not display any decimal point, whereas in the case of specifying using F format, we can even see the trailing zeros displayed. We will take one small example. So, here we are assigning integer value 40 to I, and there is one floating point value 839.21 to the variable x. Now, we will change the print format in various ways. We will explore how actually the output is getting displayed. So, I use %d, I use %5d which uses m value to be 5. I use %-5d which uses the m value to be -5, and I use 5.3d which is nothing but using m value to be 5 and p value to be 3. So, we are now using 4 types for printing the value I. So, in the first place %d will be just replaced with the plain value of I as 40, In the second case, we are setting up the width to be of 5 places. So, in the out of those 5 places, value 40 is right justified, because 5 is more than 2, which is the number of digits, and we use minus 5. So, it will be left justified. So, we are just displaying the value and then we are leaving the space. The last case will be 5.3d. Here we do not have any decimal any places after decimal point, it is an integer value, but then it is displayed using the format 5.3d. The trailing zeros is also displayed here. So, we can make a note of the format as here, and the second printf statement is 10.3f, 10.3e and minus 10g. So, here we can see the difference between the usage of f and e. So, if I am using f, I just get the fixed point floating point value representation. If I am using e, I will be getting the exponential notation, mantissa e exponent part, and the last is using g, but then it is minus 10. So, it is left justified with removal of trailing zeros. Percentage g will not allow the trailing zeros, henceforth the trailing zeros are removed here. So, these are the ways that the floating point values can be handled. Now, there are some escape sequences, which are some special characters used for controlling the output, which carries special meanings. Say for instance, alert bell, we can get an alert bell if you are using the escape sequence \a. All the escape sequences will be starting with the symbol \. \b is to give a backspace, it will move the carriage to the backspace, and \n will be used for giving a new line, freshly it will start a new line and then it will start its display. Then \t is to give the tab space of 8 characters. Supposing if the display is here and I want to give some space of 8 characters, we can make use of the escape sequence \t. How we can make use of these escape sequences in our printf statement is, just we can make use of printf, and then supposing if I am using \t and I am displaying a value, say hello. So, what happens? It gives 8 character space empty and then it will start displaying the value hello. This \t is for example. So, likewise we can make use of any of the escape sequences using the printf statement. We will be able to get monitor, you will be able to modify the output as we want. So, one printf statement can carry any number of escape sequences and any type of escape sequences. Say for example, item is displayed here, then I use \t, which gives 8 character space over here, and then it displays a value unit, then again space. So, \t, then it gives purchase and then it gives a new line. So, it gives a new line. So, it goes to the new line over here because it uses \n, and after \n again it uses \t. So, \t gives again 8 character space and then it starts displaying the word price, and then again a \t which gives some space, tab space, then it displays the value date. So, it displays the value date, then there is one more escape sequence new line, which again brings the cursor to the next line. So, this is how we can make use of the printf statement to give the format as we want. If you see here, we are now getting a tabular format. Even though it is going to be a single printf statement, we are able to get the display as a table. Okay. So, that way it is able to give us good format for display, so that it will be readable by the users. And sometimes we may want to display double quotes itself in the output, but then we are here using the double quotes for representing the format string. Then how the compiler will be able to differentiate between the format string and the symbol double quotes. So, that we can give the nested thing that the symbol double quotes have to be mentioned along with the backslash character, because if I am just using double quotes like this, the compiler will not be able to differentiate that we want to display backslash, we want to display the back quote, we want to display the double quote. So, we have to mention the character as backslash double quote wherever we want the output to be displayed as double quote. So, in this example we can see that backslash double quote, backslash double quote. So, wherever we get backslash double quote, that will be replaced with double quote in the output. Similarly, if we want to display backslash itself as a string in the output, so that can be given as double backslash. Supposing you want to include the directory path, okay. So, C:\bin, I want to display this as an output. So, how we can make it? With the help of printf statement, printf per C:* will be displayed as a string, and here we are having a backslash to be displayed. So, we need to replace it with double backslash and then the character string which we want to carry out. So, the output will just carry C:1 backslash and then bin, right. So, having learnt about the ways that printf statement can be used for displaying various values and various formats and various ways, we will now look into the way that how the formats can be applied while reading the character from the keyboard. So, scanf function is used for reading the character as input from the keyboard. So, we can make use of the conversion specification characters even for scanf. So, how we can make use of the characters? Say as we are using printf statement, here we can make use of scanf, then %t, %t, %f, %f. This is very similar to the printf statement, but here we will be adding one ampersand symbol. So, %, sorry, %i, %j, %x, %y. With every variable we are supposed to include a symbol ampersand, which is going to be different from the printf statement. So, with respect to this particular scanf statement, we are trying to read 2 integer values and 2 floating point values. So, this is the way the inputs can be given, 2 integer values and 2 floating point values. So, this will assign value 1 to the first variable I. Then the second value -20 will be assigned to the second variable, 0.3 will be assigned to x and -4000.0 will be assigned to y. Apart from printf, it is doing an additional work of assigning the values to the corresponding variables. So, that is a reason we need to use ampersand, which will denote the memory location of the variables where the value has to be stored. With respect to printf, we have checked for the number of conversion specification should match with the number of input variable. With the scanf also, the number of conversion specifications should match with the number of variables, input variables that we are supposed to get it from the user. How scanf works? So, for each conversion specification, scanf tries to locate an item in the appropriate input data, and then it will be able to skip the blank spaces, and then for the next item it will read and it will be able to store it in the corresponding variables. Say for instance, if we are using the scanf statement for reading 4 variables, but then while giving the values as input, I am giving white spaces also. The scanf function will ignore the white spaces and it will be able to read the value which starts after the white space, and then it will be able to store it into the corresponding variable. Say for instance, the value 1 will be stored into the first variable I, and then there are some white spaces that will be ignored, and from where the non white spaces starts, from there it will be able to read the values and it will be assigning it to the next variable. What if we are giving a plus or minus symbol in the scanf statement, and what if we are giving the digits? So, everything will be handled by %e, %f and %g in case of floating point variables. So, we will see some examples with respect to the floating point values also. So, if we are storing the values, if we are giving the inputs this way, the first value will be 1 will be put into the first variable I, and then it puts the character minus character back, and minus 20 will be stored into the next variable. Then there is a 0.3 symbol. So, when it stores 20, then it reads 0.3, then it is able to recognize that 0.3 is a floating point value, and then it will assign it to the variable x. Then there is an exponential format representation that will be converted as minus 4.0 into 10 power 3 and will be stored into the variable y. So, there should be a comparison between the number of conversion specification characters and the number of input variables. If they match, scanf discards the input character and continues processing the format string. If they do not match, scanf puts the offending character back into the input and then it aborts reading the values. Say for example, if you are using ordinary characters in the format string other than the conversion specification characters in the format string. Say for example, %d, there is a %d and then there is a slash character, then %d, and the input is now going to be 0.5 slash 0.96. If the input is this way, the scanf succeeds. If the input is 0.5 slash 0.96, it fails because the format string does not match with the way it is specified. So, people will always get confusion between the printf representation and scanf representation, that they may use ampersand symbol in the printf statement which is similar to the scanf statement, but these things should be avoided because the scanf will be looking for the ampersand symbol and then it will search for the next variable representation, whereas the printf will not require ampersand symbol, that has to be avoided. So, that will avoid the confusion between the scanf and the printf statements. If we want to display it as a fractional number, so how the scanf and printf can be handled for fractional numbers. So, we can take a small program. We will not be able to read the fractional number as a fraction. So, we can just read it as the numerator separately and the denominator separately, but we can specify the slash symbol in the scanf statement, so that the input can be given as a fraction. While displaying the values, the fractional value can be displayed by representing the front slash symbol in the printf statement. So, on this session's summary, we have learned how the formatting string can be specified with the printf statement in order to display the value in our required format. Also, how scanf function can handle the different formats while reading different type of values, say integer, floating point values, fixed point floating point values, and scientific notation floating point values. So, we have also seen some example programs which uses both printf and scanf for setting up various input output formats. Thank you so much for watching this session.